Okay, thank you for listening to my small presentation. In 2010, I started to learn blacksmithing, and part of the course was making hand work material, and a part of it was the bending fork. You see it on the picture. Also was part of the training, calculate your material use. And I start with that because knowing how much material you need is very nice when you start, so that you don't have a very much loss, etc. You see here the first picture is the photograph. The second picture is the technical drawing of the bending fork. And this is, do you see the result? One moment. This is live, the thing. You see it? It's about 50 centimeters long. So it's a big tool, a nice tool, easy to use and easy to fabricate, especially when you don't make it from C45. The technical drawing shows how you what you have to make. When we calculate the material use, we have a formula which is, as you can see, starting material multiplied with length is equal to become the intersection multiplied with the known length. It's small mathematics, and a blacksmith has to know how to calculate. And when I scroll to step 1, then you see what I calculated from the drawing. You see around 14 millimeters compared with the length, and the square intersection compared with the length. And what you calculate is everything from what you see on the technical drawing in volumes, because that are the known factors, and you see in cubic millimeters the volumes. You count everything together, then you see the total volume. You scroll to can you scroll to point 4 of the calculation? I hope everybody is seeing it. Then you know what the volume is of your part, and when you go to step 2 to the calculation, then you have to calculate the known length of your starting material. I choose around 30, and then the known length of the known volume divided through the intersection gives the length of your starting material. And then what I always do is making it a round number. So 178 millimeters is, in my opinion, the same as 200 millimeters. Then you have always what material extra for making falls, or when you have to use more heats, you can compensate the loss of material. Is this a bit clear to you all? That means, okay. Thank you. Is it the same way of calculating in Germany or in Finland?
I have learned exactly the same in school.
Okay, so it's the same in Germany and in
yes. You're 1 week too late. We did this last week at school.
Oh, okay. Oh, so you showed this example.
Yeah, not that example, but the same way.
Okay. Now, okay, nice to hear. Then, when there are no questions and when everybody is on the lesson, I will start to how we made it. What we learned during our course was to draw step by step the several moments of producing your tool. And you see the first step is starting with around 30. And excuse me for my bad drawing technique, but what you see is that I try to show how to flatten the round 30 to a square intersection with a bulb in it, because the bulb is what you need for the second tooth of the bending fork. You see some steps about flatten the round bar, and then you see in point 6 a bulb on the flattened bar, and it is this bulb that must to be formed to the to a tooth of the bending fork. We did it by heating it and put it on your anvil in the corner, and then use this tool. You see the hammer? Use this round hammer for stretching the material. And when you look to point 9, yes, okay, there is it. There it is. You see a part of the stretching of this tooth, and in the drawing number 10 you see the what I meant to show how you stretch this tool and how you work it to a full teeth, to full tooth. And then the next step is to bend the first part to the fork, so as it is shown in picture 12. This way of producing this tool is you have to do with 2 persons, because when you use the round hammer, then another one has to beat the beat on this hammer, or you have to put it on your anvil and make it in one way or another fasten, so that you can do it by yourself. When I produced this tool, I thought by myself, why is this way of fabricating chosen? Because I think it can be done easier with a cutting hammer, and I made a small sketch of this, and that is interesting while making tools. When you see this sketch, is it a bit to see? You can also flatten the round 30 and cut out the tooth of this bending fork, and fold it open. And you can also blacksmith one bulb, and this folding open, and then bend the head tooth to the fork. So I didn't try out this, but I think it's an easier way to work on this bending fork, and you can do it by yourself. Then you don't need any help, because cutting the material is quite easy. But that's the way we are taught by fabricating this bending fork. So yeah, that's it. I use it very not very often, because I'm not bending often big things. But well, I think it's a nice tool, and it's donated to the toolbox of IFGS. So that's it. I think C45 is a bit heavy for this tool because there aren't big forces when you use this tool, because you most use it when the iron is hot, and then it is easier to bend. So I think with normal construction steel, you can also fabricate this nice tool.
I want to know if you prefer, because in the presentation all the parts are round, but maybe sometimes it's better a square form for stronger.
Well, I think
Yeah.
I think his question gives a good point. You can also calculate to a square
Dimension.
part of material. I think the main challenge is to do a great effort with as less as possible energy. So when you have a square part, which you can easily form to reform to develop in one heat, and then you can use the material for making the parts of the fork. Then you are free to do it. I think it's a very good choice. I think that our teacher just wanted us to let us feel what C45 is. We had to forge it by hand, but most of these parts you can forge on your air hammer. So I think it was a bit let them feel what C45 is, and he also could have choose a square intersection or a rectangle intersection. And of course, you can calculate how much you need.
Great, thanks.
Yeah.
I have not a question, but you were referring to the way you made this bending fork by using a striker to forge out the second tooth.
Yes.
And most people probably know there's a great instructional video from Mark Asprey on YouTube, and he forges a bending fork as well, and he has a tool in his vise to forge out the second tooth. And I think that, yeah, exactly. Thank you very much. That works perfect. I've made a couple of bending forks as well, and then you can do it on your own without a striker, and it's quite easy.
Okay, and how do you use this tip?
Exactly
Okay.
like Patrick is showing right now.
Okay. Okay.
And then you, yeah, if I were you, I would watch the video. I can try to explain it, but the video is self-explaining.
Okay, that's
Yeah.
good.
I would actually have another point, because normally the bending forks I use are just from structural steel, and I totally agree with you. They're most of the time strong enough, unless one wants to bend steel cold. Then I would recommend this heavier material.
Sometimes in the final moments of making a scroll or something, you need to tweak it a little bit when it's quite cold. And I've broken or mutilated some bending forks in the past.
Okay.
For this reason, I use C45.
I see.
I think Patrick is going to show us a bending fork which has been misused.
No,
Oh,
no.
I thought you were
I'm
going to.
going to show you something different. So this is the bending fork I use in the vise, and it goes in the vise like this. and you can. It's just two pieces of string steel to some angle iron, straightened out, welded together with flux core weld, so it looks a bit crappy, but anyway. And the cool thing is, if you put it into the vise, which works like my fingers now work, you can adjust the distance.
Exactly.
And the
This
first
is super
time,
handy.
yeah, this is amazing. I learned this from school. And the first time I made this this part out of structural steel. These I have mutilated, but they went to the trash bin long time ago, so I cannot show, but pretty handy.
I use the parts Patrick showed in combination with the bending fork.
Yeah, me too.
Yeah.
Really, really nice.
And then maybe you already know this, but when you use a piece of angle iron in the vise for a tool like Patrick showed us, it doesn't fit that perfect because there is a radius inside the corner of the angle iron.
Exactly.
But if you grind that to a sharp inside a corner, yeah. Have you ground it sharp? Yeah, perfect. It took me several years until somebody told me this, and I would have wanted to learn much sooner. But it makes a big difference.
Yeah, that's why you need a magnificent teacher.
Yeah, if you have a good teacher, that makes the big difference. Big difference.
Everything.
So my teacher told me to do it like this. So you just forge it out to a round taper, and then you bend it and you pull like a Haberman corner. You pull that out right here, and the benefit is that your lever is at the same level at the material you want to bend. It's not over there, so some force gets lost around here. The force is directly connected about the lever to the point you want to bend your iron.
Yeah.
Yes.
So it's just another way, and you don't have to. You can also make this on your own. You just need to draw two tapers, and it's quite strong. It's not the perfect method for a smaller bending forks. I wouldn't do it like this, but if you're using it like this big and to bend all sorts of stuff, and they're quite strong and durable. And we do them from spring steel, which gets healed a few times, so there's no stress fractures from any forging or
And how thick?
air cooling.
How thick is your profile? How thick is your profile?
Ja,
Material.
ich überlege gerade, wie dick das sein kann.
Hat ich gerade vergessen, dass auch Deutsch spricht.
Das dürfte, also ich habe sie gemacht von 20er, also eine Größe. Mit einem Kollegen auf der Arbeit habe ich eine gemacht aus 20er Rundmaterial. Das man halt viel. So we made it from a 20 mil round, so we can forge a lot of material down, and we have enough material for this bend, so we can isolate it in the middle, and then we can bend it, and then we can draw this out.
Exactly.
And important is that you make like a fuller. You can lock in the vise and squeeze this onto here. You squeeze it onto this fuller, so your inside of your bending force is very exact.
Yeah.
And that's just all this. You can all do it by yourself, by hand, or I'll do it under the spring hammer. It's just a bit faster.
I've seen another way, which is also been shown on the website, which just has here like a weld. And I normally also make them from mild steel, like these smaller ones. But I have them also in bigger. So this is about a meter. And I just needed it last week to bend some 19 millimeter round stock hot.
Okay.
I was pretty happy that I had like the strong leverage at that. So I have two this size, and one went into the vise, and the other was used for the bending, and I was so happy I had that.
Yes, I have one made from 25 millimeter, and I use a pipe in the point for maybe more force. A little shorter. I think it's 50 centimeters, but I have a 2-meter pipe, so
It's always about the leverage.
yeah.
Yo.
Are there any further questions about the presentation, by the way? Just because I see we're hitting this 25-minute mark, or any other thoughts to share about this presentation?
Next time, be
I
in
think
time.
this way is really great. I love see how many ways are to make the same tool, and this I find really interesting because I believe it's row number 6 or something like that when you put in and bend the parts to make the fork. I really like.
Yeah, I think that is the what we win with this Treff, that you learn from each other, and you see many ways how to produce the same tool for the same goal.
Mm.
That is really an advantage. Yeah, I like it.
Yeah, because sometimes you really need move a lot of material, and maybe techniques like yours, you need work less for the same result.
And what I think interesting is how you can do how you can achieve the biggest result with less of energy, less of effort,
Mhm.
and high speed.
Yeah.
And I think you can learn every day from each other.
Yeah.
And one is more experienced than the other, so let's keep on going with this.
Yo,
I'm looking forward for the presentation of Otto 2.
yeah. So since I just assume there are no further questions or additions. I would like to thank again you, Paul, for the preparation of this presentation and holding this presentation. And thanks to everyone joining the Treff this day. Next time will be on January the 25th and held by Emil and be about forging without fossil fuels. Ich erzähle noch mal kurz auf Deutsch. Danke, Paul. Vielen Dank an alle Teilnehmer. Am 25.01. ist der nächste Präsentation im neuen Jahr. Der wird gehalten bei Emil. Es geht um nachhaltiges Schmieden. Emil erzählt noch ganz kurz, worum es geht auf Deutsch, und ich übersetze das danach auf Englisch.
Ja, es geht darum, dass das Schmieden mit Kohle und auch mit Gas relativ ineffizient ist. Abgesehen davon ist das Nutzen von Kohle und Gas halt auch nicht mehr ganz zeitgemäß. Und es gibt halt zurzeit ein paar Alternativen, die sich auftun, und da wollte ich einfach mal kurz vorstellen, was da so gibt, und vielleicht auch einfach mal eine offene Diskussion starten, wie die anderen Menschen zu stehen.
Das ist ein Schritt nach Innovation, Otto, oder?
Ja.
Ja, ich bin sehr gespannt.
Hast du es schon ausprobiert?
Leider noch nicht. Ich habe keinen Induktionsofen und mir fehlt auch gerade der Platz dafür, abgesehen davon, dass es ja auch entsprechend viel Kleingeld mit sich bringt, das so ein Ding kostet.
For everyone who is not so well in German, so the next presentation will be about alternatives to fossil fuels, since coal and gas are so yesterday. And Emil wanted to express that there are different options and alternatives now available, and start a discussion about that.